For question number 2, it's a dimensional analysis question, and it's asking me to investigate the plausibility of this equation for values of n equal 1, n equal 2, and it's telling me t represents time, a the acceleration, the v's are the velocities. Okay, so the first part of it is asking what are the dimensions of the left hand side for n equal 1. So for n equal 1, the left hand side then will be v plus v naught over 2a, and the dimensions will be, we know that when I add two velocities I get a velocity back. So v plus v is v, so I get an L over t, or lt minus 1, over 2 is dimensionless constant, and a is the acceleration, which is L over t squared, or also can be written as L t minus 2. The L's will cancel, giving me 1, and the t's, one of them will cancel with the minus 1, and will leave me with 1 over t to the minus 1, which is the same as t. So the dimensions of the left hand side for the value n equals 1 is t. What are the dimensions of the right hand side for n equals 1? So dimensions of, first of all, when t to the power 1 minus 1, that's t to the power 0, that's equal to 1. So v naught t to the power 0, this I know is going to be equal to 1, and it's minus a t to the power n, which is substitute for by 1, then I know it'll be minus a t. Okay, so that is equal to L over t for the velocity, minus the acceleration is L over t squared, times time. One of the t's goes with the squared, so I'm left with L over t, and it's L over t minus L over t, that's equal to L over t. So for part C, it asks what are the dimensions of the left hand side for n equals to 2. So that means v squared plus v squared over 2a. So the dimensions of v squared plus v squared over 2a, v is L over t, so v squared is L squared over t squared, or L squared t minus 2. And the 2 is the dimensionless constant, and the acceleration is length per time squared. The theta minus 2's cancel with each other, and one of the L's goes with 2, and I'm left with an L. Part D asks what are the dimensions of the right hand side when n is equal to 2. The right hand side is v times t to the n minus 1, so that would be t, because 2 to minus 1 is 1. So v naught times t minus a times t squared. So I'm looking for the dimensions of v naught t minus a t squared. So that's equal to, v naught is a velocity, so length per time, times t is time, minus the acceleration, which has units of length per time squared, multiplied by times squared. Times squared cancel with times squared, I'm left with length. Times cancel with times, I'm left with length. Length minus length is also a length. For part E, it's asking, based on the dimension analysis alone, for which values of n, either n equal 1, n equal 2, or both, or neither, is this equation plausible, and why? So for n equals 1, we got that the left-hand side is t, and the right-hand side is L over t. The dimensions don't match, so n equals 1 does not make this equation a plausible equation. For n equals 2, we found that the left-hand side is equal to the right-hand side dimensions is equal to length. So that means that for n equals 2, this equation is plausible because the dimensions match. Dimensions of right-hand side is equal to dimension of left-hand side is equal to length. And that concludes question 2.